we're done with the Abdurrahman's form, let's move on to the center of the city. Allow me to present my project, titled The Impact of Urban Progression on Greenhouse Gas Emissions, a case of the BRICS countries. This will be our agenda for today. So let me start with a little story. We as humans evolve every now and then, and our evolving mirrors where we choose to live. At first, in the old ages, we started out in farms and started out in villages, and then thanks to technological progression, we've moved out to loud, bustling cities. However, this evolution of where we choose to live also has a side effect that might be impactful on the environment. So in this paper, we try to understand the impact of urban progression alongside other variables on greenhouse gas emissions in the BRICS countries, which is the newest economic organization to date. So our research questions go as follows. We try to know the effect of urban progression, per capita GDP, deforestation, industrialization, FDI, and crude oil production on greenhouse gas emissions. So for the research background, as we can see, there is this graph that depicts the urban progression of Brazil from 2003 to 2022. The urban progression in Brazil was influenced by the creation of the Federal District of Brasilia. And the same trend, almost the same trend goes on for India, and urban progression in India started after the 1991 economic crisis in India, after they implemented employment and job creation policies. The same trend goes for China. The urbanization process in China was influenced by the Great Leap Forward program, as also other urbanization programs. And finally, and for South Africa, the urban progression was influenced by internal migration, as urban development in South Africa was not equal. Some places got more urbanized than others. Of course, that was because of the apartheid. And now here we move to the last graph, Russia, which has a very interesting U-shaped dip. What happened here is these are the residual effects of the Soviet policies. The Soviet Union tried to reallocate the citizens of Russia forcefully into mid-urbanized areas that are not very urbanized. And now we move on to the theoretical framework, and now we have the spatial equilibrium model. The spatial equilibrium model is influenced by von Thunen's agricultural location theory, and what the theory says is that when an area has better amenities, has better business opportunities, has better services, people are more likely to allocate to it than other areas. And here's the urban metabolism.
Yusuf, can you please stop yapping? You're not an engineer.
Let me continue.
No. Okay, so urban metabolism is a concept borrowed from the vast field of engineering, which was developed by Abel Woolman in the 1960s as a method to quantify the flow of materials and energies in cities. Urban metabolism establishes cities as organisms and tracks the movement of resources and energy in and out of cities. The concept was further developed to include technologies and socio-economic changes in cities.
Okay, thank you. So, moving on to the empirical point. Past research papers have shown that almost all of our chosen variables have a negative effect on greenhouse gas emissions. However, urbanization has a double effect. Some papers thought that urbanization affects the environment positively, and some other papers thought that they affect the environment negatively. So, based on the past research papers, we hypothesized that all of our independent variables have a negative effect on our dependent variables. And this is, we chose panel data, and this is our equation, which includes, as I said before, urban population, GDP per capita, forest areas, FDI, industry as a percent of GDP, and crude oil production. So let's take some insights from the descriptive table. So as we can see here, we have several disparities in our independent variables. Most of these disparities are the maximum minimum value, and most of them are created by the country of South Africa. As the country of South Africa has so little forests and so little crude oil production. However, very interesting insight right here is the difference between the maximum and minimum of per capita GDP. The maximum depicts Russia's effort in the international trade scene, while the minimum reflects the Russian economy during the 2009 financial crisis. Onto the correlation matrix. Almost all of our variables are significant, and all of our variables have a relation. However, if we look at the correlation between urban population and FDI inflows, we find that there's a high correlation and high significance. This is because in countries like China and other Asian countries, FDI is injected in the country in order to build new cities and new communities. Okay, for the Unit 2 test, our variables didn't show significance at level. However, when lagged for the first difference, most of our variables showed significance, so we reject the null hypothesis. And on to the econometric model. So the econometric model shows a positive relation between most of the variables, most of the independent variable and our independent variable, which is greenhouse gas emissions. However, but for GDP per capita and forest areas. Our R squared is equal to 0.81, which means that our independent variables explain 81% of the change in our dependent variable. Moving on to the OLS model, the same results are consistent with the robust least-squares, and the F statistics shows high significance, which means that the significance of the whole model. However, the Durbin-Watson value is equal to 0.11, which means that the model suffers from positive or correlation. So to deal with positive or correlation, we tried to use the GLM model, and the results are also still consistent with the past two models. Okay, on to the normality test. As we can see right here, the probability is equal to 30%, which means that we reject the null hypothesis and that our model shows normal distribution. And on to the heteroscedasticity test. At 5% level of significance, we fail to reject the null hypothesis, and our model is homoscedastic. Okay, on to the description of hypothesis. So most of our variables came out as not supported, and only two came out as supported. However, if we hold our main variable, which is urban population, we can see that it's partially supported. When looked into that, research says that it depends on the size of the urban agglomeration itself, which means that urban agglomerations of more than 1 million residents are more likely to increase greenhouse gases in that area. And so 1 million residents is the threshold. Lower than 1 million residents, it won't increase the greenhouse gas emissions. If more than 1 million residents, it will increase the greenhouse gas emissions. Okay, so we looked at our drivers. We looked at the effect that our drivers have on greenhouse gas emissions, and most of our drivers have shown that they have bad effect on greenhouse gas emissions. Only for per capita GDP and forest areas, they show that there's a positive, good positive relation. This is due to forest policies being implemented in those countries of the BRICS to reserve those forests. Okay, on to recommendations for the government and for firms and for individuals. For governments, there should be more or better urban migration policies in order to not pass the threshold of 1 million residents and to have lower greenhouse gas emissions. Also, better forest protection policies must be in place. For firms, firms should implement better production techniques, more sustainable production techniques. And for individuals in urban areas, in highly condensed urban areas, using an electric vehicle is a better option because it doesn't have high greenhouse gas emissions. Also, the implementation or the use of solar panels would be sufficient in order to have a clean source of electricity. And for the limitations that I faced when I was doing the paper, there was a problem with urban population as an index because urban population as an index didn't divide the urban areas into suburban areas, metropolitan areas, main cities, because according to research papers, there is a difference in emissions between every and each one of those. Those are my references, and just before I finish, I want to thank Dr. Zach, Dr. Megan, Dr. Isma for coming today. I've had a short 3 years in this university, but in those short 3 years, I've learned a lot, like really a lot, and I've developed from the first year to the last year, and I'd love to thank the dean for supporting us and being our friend, and also Ron, because I love the name. Yes, that's